good evening. No, good afternoon. How's it going? Today I'm recording the YouTube video earlier than usual. Today I got up a bit later than usual, but I had to go to the grocery, so I was in a hurry to go there and had a lunch. And now I'm recording. But right before recording, a bit a bit minutes ago, I have already taken the English conversation lesson on Native Camp because I just turned on the PC and I found my favorite tutor online and available. He was available. So I just hit the take class button and I enjoyed chatting with him. And he asked me that how do you memorize or find new vocabulary to study? I answered him to that I usually watch anime or video on Netflix or YouTube and I record this kind of speak video, improvising speech. So I put it into the AI tool. AI tool usually recommend or suggest me that you should be you should have used this sentence or this vocabulary, and then I try to memorize and add it into my active vocabulary. So that is my strategy to memorize vocab in English learning. But now I think this is a good strategy because, say, mm, when I record the video, this is a real setting, so it's not like imaginary situation. So I believe that that's stick into my mind. That help me that vocabulary stick into my mind strictly. And similarly, if I watch the movie on Netflix, that obviously usually give me the specific display or movies in real setting. So that also give me the chance that the vocabulary stick into my mind. Okay. And today, how are you doing? Today is Monday, so the grinding has begun. And by the way, today, my friend living in Australia is taking his surgery. And in my history, I haven't experienced the surgery. And I usually chat with him on Instagram and he messaged me that like his message was really positive. That is, I think that is neat, awesome, dope, because I'm easy to get scared. And if I had to take the surgery, I would be scared and become really nervous about it. But he wasn't. I'm really proud of him and I'm rooting for him. Today is the very day that he takes the surgery. I hope that everything will be well and he's okay with everything and wishing his speedy recovery as well. Now I'm waiting his message from Instagram. But I have I'm convinced he's okay because he's really strong and bright person. Okay, so without further ado, let's dive into today's topic. Today, I gonna practice my English speech again. Just a moment. I have to open it immediately. Okay, let's give it a try. Okay, today I'm going to talk about the initial meeting. No, today I'm going to talk about the thesis of your internship starting the end of May. Okay, in this presentation, I will cover four main topics like our product, the software you will be working on, your challenge during internship, and pre-study. Okay. And at first, I want to talk about our product. We have several category of product and our development specifically develops board testing equipment. We call it ATE, stand for all testing equipment. The product looks like this. This is a brand new product, FA1823, and look into the inside of the machine. Here is the inside of the machine, and there are four independent robot arms with probes. Now probes hit the pads on the circuit board to inspect patterns created as correctly as designed. Okay, when it comes to board, that looks like this. I believe that you are using electric devices including PCs, smartphones, and PC monitors, laundry machine, and stuff like that. We can't picture the life without the electric devices. And electric devices, there are numerous electric components mounted on the circuit board. Circuit boards allow the electric devices to connect electric component appropriately, then that works well. This is a very pivotal component to create electric devices. Okay? And then let's dive into the testing. We have mainly two methods of inspection. At first, continuity test. Here, this is the image of the electric board, and now this is a pattern, and two probes are hitting this pattern. Okay? The situation is here, and then we apply a voltage and current, then we can measure the resistance of this pattern. And then if the resistance is lower than the reference value, we judge that this is connected. So this is ideal pattern, connected pattern. So if the resistance is low, then we we inspect and judge this pattern is good, no problem. But on the other hand, if the resistance is higher than the reference value, then we inspect this is open pattern, a defect. Controversially, we also have insulation test. This pattern should be separated. Okay? Then, in this case, the probes hitting one pattern A and another probe is hitting pattern B. Then we apply the high voltage between two patterns. Then the resistance is quite high. Then we can judge these patterns are separated correctly. But just in case, no, by any chance, the two patterns, the current flows a bit, slightly, then we detect the short pattern, a defect. So our product, ATE product, lead to this inspection features to inspect and judge this electric circuit board are manufactured correctly. And then we have a question. How do we find this testing point? Okay, in this case, testing point should be as far as possible, like point A and point B are far from each other as much as possible. Then, how do you decide? This is the challenge to our product. Now we have the software to solve it. UA 1718 February. This is the software you will tackle during internship program. Program. Okay. And this is one page of catalog. And this software lead to testing point generation and GABA data editing. Yes. At first, PCB board are designed by CAD software, but when it comes to production line, then they are using GABA data. So that's why in production line, GABA data is very useful data format. So in our product, we have to deal with GABA data. And I've already read your resume. That was quite awesome and fresh. I was really impressed when I read your resume. Nice. So that says that you already experienced PCB design, right? So I bet you already know this format. But now I try to walk you through briefly GABA data. See, this is a one picture of our software and showing the layout design of the board from GABA data. GABA data is like a set of vectors and consists of aperture, lines, arcs, or polygons. Okay? So aperture is like the shape and size of the tool, like the tip of pen. And lines are defined by moving the aperture from point A to point B. See, can you see this pattern? And the edge point of this line, you can see the circle. This is aperture. And then aperture is moving from this point to this point. Then the line has been created, right? So this is a line powered by Gerber data. And here, this is like circle. And if you use aperture and flashing at a specific point, then this path has been created. So aperture is used for creating lines and aperture. And also, similarly, arcs are created by moving point A to point B with specific angle and radius. Okay? And furthermore, we have polygons. A common rule in creating polygons is that a path drawn counterclockwise is a field data. But I'm so sorry, unfortunately, in this picture, there are no polygons. But probably during the development, you will face polygons. Don't worry about it. Okay. And then we've already gotten the layout data of the circuit board. Then how do you identify the end points of the patterns, probing point from Gerber data? And in that case, February, our software product already have the feature to lead to generating the probing point. For example, magenta pattern, you can see the magenta pattern, and this pattern are already connected electronically, and at the first glance you can't understand this pattern and this pattern are connected, but actually through other layers using beer, the magenta patterns are connected. Then you can decide the probing point here and here, because probing points should be placed as far apart from each other as possible, like the left image. So to wrap it up, our goal is to both generate probing points for inspection, and in order to realize that, calculate the connection data from Gerber data. So let me walk you through more specifically. Current our challenge are following. PCBs are becoming denser and more fine-pitched year by year. And existing algorithm cannot handle this level of complexity, where patterns are smaller than 1 micrometer and both sides 1 meter by 1 meter. This is maximum size. And our current software is not capable of handling high density PCB data at the required speed and precision. Okay? So our goal is to develop a new algorithm built for high density PCB data. And also, this is your challenge during internship program. So, okay, let me walk you through again. The objective using this raw text-based data, Gerber data, calculate where the testing points should be more quickly and precisely. And in order to realize this, in order to make it happen, this involves two major technical hurdles. At first, identifying endpoint. How do we accurately find the termination of each pattern? And second, distinguishing connections, like connection group decompositment. How do we distinguish between different connection groups electronically, especially in multi-layer boards? So your challenge is develop a new function that overcome that hurdles. And then I have one thing to talk about additionally. Our objective is here. And I suggest you have to develop two things here, but you don't have to follow what I said. Only if you can realize our objective. You can develop freely. Don't hesitate to suggest new things to me. This is really pivotal thing. Okay. Let's move on another topic. Pre-study. We request two things to study in advance: Visual Studio and Gerber Data PCB structure. But I guess it's not challenging. It's really easy for you. Okay, that's it. So I'm looking forward to working with you. So I hope safe flight from India to Japan. See you soon in Japan. Okay, thank you. Okay, thank you for listening. My presentation practice, that's done. And also, I hope you have a great time on Monday as well. Thank you for listening. Bye.